Hey, good morning, class. Mr. Bean here, going to do a presentation on lesson 8.5, which is going to introduce us to Ohm's law. And we can see over here, lesson 8.5, the objectives after this presentation. You should be able to define and calculate electric current, define and calculate resistance using Ohm's law, explain factors and calculate the resistance of a conductor. Some vocab, we should become familiar with voltage, current, amps, ampere is another way to express that, volts, ohm, resistance, and resistivity. So in here is electric current, and I'm going to highlight just some main ideas here. Electric current is the flow of charge, okay, just like water, okay, very similar to water, and it has the units of amperes or amps, which is right here. I'm going to try to not say so much. Electric current has the symbol I, which will be used quite frequently, and is measured in amps. And this here is the equation. It is I is equal to delta Q, which is the amount of charge divided by T, the amount of time that this much, so amount of charge passing through a current at a given amount of time is what current is. So you'll want to answer these questions on Socrative, and the room code is AP85. So here's some questions here about Coulomb. Here's question 12. Some calculations here using this equation up here. 12.3, 12.4. Here are some possible answers. And you'll work through this until we get to the next topic of resistance. So electrical charges can move easily in some materials, which are called conductors, and less freely in others, which are called insulators. The material's ability to conduct electric charge is known as conductivity. Hold on here. I didn't want to do that. Let me go back, undo. So called conductivity. And good conductors have high conductivities. The conductivity of a material depends on several factors. The density of free charges available to move and the mobility of these charges as well. In similar fashion, material's ability to resist the movement of electric charge is known as resistivity, and it has a Greek symbol rho, which looks kind of like a funky P here. Resistivity is measured in ohm meters. Okay, ohm meters. Let me get that down here. Ohm meters. Both conductivity and resistivity are properties of the material. When an object, okay, we do some more reading here. I don't want to get you too bored. Down here is the equation for resistance. Okay, resistance down here. And it is measured in ohms. Okay, and the units of resistance are in ohms, which looks like a horseshoe shape right here. And it's measured in ohms, and this is the formula here. So it has to do with this, so what was rho again? So rho up here was resistivity. It's a constant, okay? Each material has its own resistivity. So this is resistivity here, and this is that funky looking P. So it's a property of the material itself. So resistance is simply what rho is, resistivity times the length of the conductor or wire divided by its cross-sectional area. Okay, in this formula, the resistance of the object is in ohms. Rho is the resistivity of the material, and L is the length of the object, and it's in meters, and A is a cross-sectional area, and it's in meters squared. So these resistivities are based on 20 degrees Celsius. As you heat materials up, their resistivity or resistance can change because of the wild nature of electron movement as they don't move in a nice linear pattern. They're scattering around, bumping into each other, and that happens to increase as you increase temperature. So there's some questions here about how to calculate resistance here, 1205, 1206, and here's 1209. Here's a hint to help you possibly get started. Here's 1210. And again, here's some hints on help you get the answer. And then finally, we're going to come down to Ohm's law. So Ohm's law, there's a relationship which a guy named Ohm came up with, and it has to do resistance, voltage, and I think this should be R here. No, this is current. So resistance is equal to voltage divided by current. Sometimes if you rearrange it, you have current is equal to voltage divided by resistance. Okay. And this is Ohm's law, a little introduction here, and here's some more information here about Ohm's law. Some more questions here. Some more questions. And here is something to note here. Ohm's law isn't truly a law of physics. Okay? Not all materials obey this relationship. However, if you do an experiment and you were to plot voltage versus current, the slope here would be resistance. When it is linear, it is following Ohm's law. When it's not linear, it is not following Ohm's law. Okay, here's some more stuff here on electric current, but I wanted to talk a little bit about voltage or potential difference. Let me go through here, electric current. Okay, voltage. Okay, so let's go up here. Let me find a blank spot here. Here, let me do this for voltage real quick. Let me minimize this, and let me open up a new window here, and let's do docs here, and I just want to give you a quick description of voltage. And let me go here. Let's do new, and so we can kind of see what's going on here. Okay, so voltage. So essentially, think of it like this. Here's a hill, and up here at the top of the hill, we have a lot of Q's. So we'll call this Q, and these are, think of this as current or electricity, or hold on, let me do this instead. Let's do, these are all electrons. Electrons, 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 and electrons. Down here, we may have like maybe only three electrons here. So up here we have 1, 2, 3, 4, 5, 6, 7 electrons up here. And down here we have only 3 electrons. So if we remember, electron rich seeks electron poor. So we have a whole bunch of electrons here, and we have 3. So this is called potential difference. When you have a difference of electrons here, this is the term called voltage, which is potential difference. So here's voltage, and we will call it potential difference. Potential difference. We'll go right here. It's called potential difference. It's measured in volts. Okay, and so what happens is that here we have voltage, and what's going to happen is that these electrons are going to flow down here to a place of low potential difference. This is high potential difference. This is high potential, low potential. So it flows from high to low, and this is where we get what's called current. This is current flow right here, and it has a lot to do with high to low. This is where current comes from. So potential difference causes current flow to occur. Now, before we leave, I'm going to try to find a cartoon here called Ohm's Law cartoon. And let me try to find that real quick here. And this will help us understand Ohm's Law much better. Let me go new here. And Here we go here. And take a look at this here. This guy here is ohms, which is causing a tightness to occur. Amps is the current or the electrons flowing, and voltage is giving the oomph. So this picture here really illustrates V equals IR, which is Ohm's law. I prefer this method, but sometimes it's written like this. This is I, and this is, so I is equal to, was it 1 over R times voltage. And just remember, if you were to graph this, it might look like this, where this is Y equals mx. But this is a good illustration of how Ohm's law works with voltage, resistance, and amps. Remember, ohms has this symbol here for resistance. Voltage is V, and amps is going to be, current flow is going to be measured in A, or amps. All right. Hope this works out for you guys. Any questions, feel free to contact me via Remind, email, text, or on Google Meet.